It's now my pleasure to introduce the next session of this GNF evening of today, and this is focusing on one of our upcoming big events, not the IEC yet of Baku in 2023, but the IEC in 2024 in Milan in Italy, which is under the theme Responsible Space for Sustainability. And that's also the title of this GNF session that is moderated by Tiziana Paradiso from the International Affairs Directorate of the Italian Space Agency. And I would like to ask Tiziana to come up.
And good afternoon, ladies and gentlemen. Thank you for being here for this GNF on IAC 2024 in Milan, Responsible Space for Sustainability. I'm Nunzia Paradiso, Tiziana, as many calls me, from the Italian Space Agency. And I'm honored to moderate this panel. Without further delay, I give the floor to Professor Carrera, Professor of Aeronautics and Astronautics at Politecnico of Torino. Also president of the Italian Association of Aeronautics and Astronautics, and co-chair of the IAC 2024 Local Organizing Committee. Professor, please.
Yeah. Thank you, Nunzia. So I can see you better. So thank you, Nunzia, for the introduction. Of course, we are here, and you see we have several speakers. I'm just here to tell you a little bit more about what we are going to make it in Milano and what is our way to Milano 2024 IAC. So you see in this picture the location. So, but this is the Mico is the place where we will have the IAC Milano. So you see, we will have a very large exposition area, about 15,000 square meters, and we do expect more than 10,000. Okay, so we would like to make a record. Okay, and of course, as you know, the AIDA is the hosting society, but we are working with Italian Space Agency and Leonardo all together. Next slide, please. So you see here what we are doing to come to Milano. So we got the IAC in Dubai, and then we had first meeting in Milano in April in the spring 2022. Where we propose to the city of Milano and to the authority there and the local industry there the event. Then, we made the contract last year in presence of past President Pascal Ehrenfreund in Lombardy region headquarters, and then we were, of course, in Paris, and okay, so it's okay. Then we had starting this year by having some events in Milano. There was a quite interesting event. We call this "Looking Beyond," which were hosted by Telespazio mostly. It was very interesting exposition, and now we are here. We will be in Oslo as well. And for the Glock, and then of course in Baku, that we know that Baku is quite successful event, and Italy, it seems that is playing a very important role because we are the second country as far as the number of abstracts there, and we are also taking as first country for the exposition area. So we are doing our work to make Baku a successful event as well. And then, of course, we will come again to the spring meeting next year. And then, of course, in Milan and probably other events you will have earlier. Next, please. So, we are very much connected with the Italian government as well. We have the strong support of the Italian Ministry of Cooperation and of Enterprise. They are going to help us also in the framework of the 3G program, so to increase the participation in emerging countries and the young professional and so on. And we are preparing our sponsorship kit. It will be available in a few weeks from now, of course, but we will start to work officially on it after Baku. And this will be ready, of course, in the next month. So please, next slide. Yeah, but now, we have chosen this motto. Okay, this is very, very important. I want to just underline, so personally, my experience, that people talk more about sustainability, but not much on responsibility, So we put these two words together because for us it's very important that everyone is really committed as responsible, because only with a responsible, attitude to space we can have sustainable space activity. And we will have our colleagues later than the video of Giorgio Sacoccia that is trying to come several times, but we stop it. It's not a star. So he will come. But then we will have two important, I think, speech from colleagues of AIDA on that. So thank you, Lucia.
Thank you very much, Professor Carrera.
Yeah.
So our program included the participation of the president of the Italian Space Agency, Giorgio Sacoccia, but unfortunately he could not confirm his presence. We have his video message. Now we can hear it, please.
Good afternoon, everyone. For the Italian space community and the Italian Space Agency in particular, the opportunity to organize next edition, the 75th edition of the International Astronautical Congress in Milan next year is an honor, a pleasure, something that we really believe we have to do at our best. It's not just because the International Astronautical Congress is one of the largest events for space activities that brings together all the operators, all the stakeholders in the world to discuss for a full week of space in every aspect, but also because every year, at the occasion of the IAC, we can see with our eyes how space is becoming more and more important for our daily life. It's not by chance that the Italian Promoting Committee has decided to use as a subject for main theme for this edition, responsible space for sustainability. This is because space is really a tool which will be essential for the future of humanity, for the future of our planet. And we are convinced that occasions like the International Astronautical Congress are the gathering where not only we can discuss about what space can do for this field, but also to create the mindset for future generation to use space as something that would prepare at best what their future will be. And because they are the one who will have to build up their future, we have the duty to transfer to them all we have built up in terms of knowledge, know-how, for them to build up a better future for themselves. And this is exactly the way I see an occasion like the International Astronautical Congress, an opportunity to transfer and share knowledge in a field so important for the future of our planet, like space activities. I'm part of the International Program Committee, and we feel the importance of the role of preparing the best content of the program for next year in such a way that we can discuss in depth what will be the usefulness of space and space activities for the future. So I hope today the speaker that will follow will have the chance to present a bit more in detail which are the ideas of what space can do for sustainability. But I'm really, really looking forward and invite everyone to be in Milan next year to share ideas and to feel with direct exposure what space will do to serve humanity for the future.
Very well. So now let's focus on the motto that was chosen for the IAC 2024 in Milano: responsible space for sustainability. We all know that resources are limited, but this is true not only on Earth, also in space. The need for conducting human activities in a sustainable way is paramount. But sustainability in space is also paramount because of the importance that space technology has for the life on Earth. Our daily life is pervaded by important services and applications that need space technology to function and that help us in our efforts to develop our societies in a sustainable manner. So acting irresponsibly in space or simply with superficiality not only put at risk the safety of space activities, their sustainability in the long term, and ultimately the needs and rights of future generations to conduct them, but also, and most of all, put at risk the provision of those important services and applications that space activities enable and from which we depend now on Earth. So, sustainable and safe use of space for the sake of sustainability of both space activities and, most of all, Earth activities will be the leitmotif of the IAC 2024 in Milano. So I'm very glad to introduce Professor Nicole Viola from Politecnico Torino and Professor Camilla Colombo from Politecnico of Milano, who will share with us their views and some results of their studies on such topics. So please, Professor Viola, please.
Okay, so thanks a lot. Good afternoon, everybody. Space for all. So we would... Yes. Yeah. The green one. Okay, thanks. Space for all. Of course, we want to have and we will have a sustainable and responsible space for all. Space can really help mankind reach the sustainable development goals that we see here. There are many. I would just like to pick one of them to give a bit of introduction on the motto. Let's have a look at the number 13, so to protect the planet. We are all aware that the climate crisis is the most urgent challenge that humanity is facing right now. I have to add the green one. Okay, sorry. Okay, we have natural and human-made threats caused by climate change that are putting all of us at risks. But space can really provide assets, can really provide solutions for our climate and for Earth. There are many solutions that can be mentioned. I would like to mention one: climate reanalysis. What is climate reanalysis? I think that this picture really shows clearly what is it. Observations of our climate made in the past are very few, and they become fewer and fewer if we go back on time. They are not heavenly distributed on our Earth. So it is very much like having a puzzle where there are pieces that are missing or some other pieces are overlapping. So what is climate reanalysis? Climate reanalysis is like a smart machine that combines observations made in the past with climate models to reconstruct the world picture and really give a consistent view of the climate on Earth. And it is very important, this, for all the climate scientists that we have today, because this consistent picture allows us to understand how climate on Earth is evolving in the past. So we have trends, like trends of the Trends. Oh my God. Oh yeah. Okay. I'm at the end. I'm sorry. I'm starting. Maybe it is better if someone else is. Yes, please. So we're. Okay, it's finished. But I can continue. I can continue even without a slide. Okay. Yes. Thank you, Camille. Now maybe we can. Yes. Oof. Okay, so we had trends. We can understand, thanks to the climate reanalysis, we can have a more accurate view into the future and try to predict what will happen to the climate on Earth in the next decades up to the end of the century and beyond. To better understand climate hazards, weather hazards that are crucial, this is a very nice example of clear air turbulence, because we always talk about the impact of aviation onto climate, but there is also vice versa. So the impact of climate change on aviation safety. There will be some weather hazards that will cause serious threats on aviation safety, and one of these is clear air turbulence that we have all experienced in flight. So the results reveals that clear air turbulence will increase about more than 100%. In both hemispheres in the next decades. But this is just according to the worst case scenario, of course, of doubling CO2 emissions. But this is just an example. We can move on. Yes. Yes. So this is a nice picture. And it tells us a very important message. So space, we said, it is a very valuable asset to protect our climate, but it doesn't come without a cost. What is the cost? Space technologies do have an impact themselves on our climate. So for this reason, we need to build a sustainable space and responsive space. If we look at this picture, we understand that launchers emit species, chemical species and particles through our atmospheres, different levels. So we have here troposphere, stratosphere, mesospheres, up to the carbon line and beyond. And this is producing a serious impact at different levels. So we have a local impact, around ground, let's say the spaceport level, where we are damaging air quality, we are damaging live species. But we do also have a global impact at higher altitudes, so stratosphere altitude, where we are, let's say, increasing or decreasing radiative forcing, and we are contributing to the ozone depletion. Of course, next slides. It is very different, what type of emissions we are talking about and what is the climate impact that we are causing, depending on the type of propellant, the type of propulsive technologies, and the overall configuration of launchers. Reusable versus expendable, horizontal takeoff versus vertical launchers. So it is incredible. There is a difference, of course. And here are just some numbers where we have compared launchers that are launched vertically with respect to horizontal launchers that have many other problems. They might be good from the point of view of environment, but of course, many other problems. Next. Just some numbers, because, okay, we might think that overall the impact of rocket launchers, is negligible, is very small now, and this is, of course, true. 200, hundreds of launchers per year do not cause a serious threat. But if we think that the launches will increase up to a rate of, let's say, 1,000 launches per year, then the impact on climate will be comparable to subsonic aviation. And here are just some numbers, just to have some ideas of tons of chemical species that we are emitting. When an A380 flies, in one flight we have hundreds of tons, about 400 tons of emissions, pretty much as Concorde, moving up in speed. If we talk about hypersonic aircraft, civil passenger aircraft, we have one order of magnitude higher, so 1,000 or 1,000 of tons, and the same holds true for launchers. So for launchers, we talk of thousands of tons, and then of course it is different. Last slides, thanks, go on. Of course, not all emissions are the same, so tons of emissions are not all the same. It depends very much on the chemical species that we are emitting. It depends very much on the altitude and the latitude. So I'm not going into the details, but just to give you some information, the water vapor emission, which is not a pollutant emission, but still is a greenhouse gas, the higher is the emission, the worse is the impact on climate. And it also depends on the latitude. So recent results reveal that tropical latitudes are worse for the climate impact. Polar altitudes or higher altitudes are better. So it is really, there is a lot to study. So this is really research topics that deserves a lot of attention, but we need to do that. Thanks.
Thank you very much. Very interesting, Professor Viola. Professor Colombo, please.
Good evening, everybody. So we have seen how space is important for our daily life. We all know that space is offering many services to our daily life, like remote sensing of all the conditions on the Earth, climate change monitoring, the study of the solar activities, but also geolocation, weather forecast, telecommunication. And if now we imagine to live a life without the Earth, without space, what we could do is to map all these services in very simple icons. But behind these icons, there are all the data from satellite or all their payload, what they do, and we map them in all these services. And if now we imagine living without space, we would see that all these icons, little by little, would turn off, and therefore all the location on the Earth ground would become darker and darker, as our knowledge of the planet would be without satellites. And therefore, we can say that thanks to satellite, thanks to all the data that we can get, for example, from satellite for Earth observation, we can achieve, or they help us to achieve, the Sustainable Development Goals, as Nicole said. But we can go even further, because we can really evaluate that. We can assess that in a quantitative way, because by modeling the payload that the presentation is in strike because it's going on by its own. What we can do is really to evaluate, to assess the impact of satellites and mission to Sustainable Development Goals, because we can model their payload, we can model their coverage, we can model the data, we can compare those data with actual data, for example, available thanks to the Copernicus service. And we can map all this information in terms of frequency, of coverage, of repetition time, of location on the Earth. We can map them to the Sustainable Development Goals. And therefore, for each mission or for each series of missions, in here I've shown the family of Sentinel satellite, we can evaluate how much each of these satellites or each of these family is helping us to achieve the Sustainable Development Goals in the graph below, or in the graph above, is helping us to develop new services for different applications, like hazard monitoring, building, agriculture, wild nature, and so on. But as space is helping the development of a sustainable life on Earth, at the same side, we know that this is made possible thanks to the many satellites in orbit. And also, we all know that there are many space debris, so many production of this mission that were left in orbit. And if now we imagine of launching the Apollo mission 50 years later, the actual launch, so in 2019, The one you have seen would be the view that the spacecraft on the trajectory to the moon would have to see in 2019. Of course, in this simulation, the debris objects were enlarged for visualization purposes, but the orbits are the actual orbits. And therefore, space sustainability and the contribution to space on Earth is very connected to the requirement of being sustainable ourselves, so developing in the future space as a sustainable ecosystem. And indeed, if we look at the number of space debris, this graph comes from the ESA report with the space debris number, we can note a very similar analogy with many other environmental issues. Many other Earth system trends which represent environmental stressors like carbon dioxide, tropical forest loss, ocean acidification, terrestrial biosphere degradation. And this analogy again highlights the fact that we need to develop sustainable space activities and we need to act right now, because this behavior is the behavior of all the other systems on Earth that are already in the danger zone. The typical exponential behavior of all the environmental problems. And this also shows that we can maybe consider space beyond the atmosphere as part of our biosphere, as part of the extension of our biosphere, of our Earth, that now extend up to at least geostationary orbit and beyond. And so what are the solutions? Because we created problems, but we are also good in finding solutions to them. The important aim is to define mitigation guidelines, but in particular to define an internationally recognized and accepted approach to measure the overall space carrying orbital capacity. So how in the future we can exploit space in a sustainable way so that the space environment will not be only clean from the pollution point of view, but also free from, for example, the collision risk point of view. And this would be possible if we learn how to define a way to measure the overall space capacity in the long term, but also in the short term, and how to connect this space capacity to space traffic management that instead is already developing internationally. And we need to learn and to define altogether how to measure this. Like, for example, now we learn how to measure the impact of climate change with, for example, CO2 emission. But also we need to define a threshold for this measurement of the space capacity. Only at that point we will be able to link such measure to the contribution that each mission can apport to it. And this will help us to support the definition of mitigation guidelines that are already there, but they most probably need to be adapted to this very quickly changing space environment. And just to give an example, I want to show you a possible solution. This graph shows the so-called fragmentation effect map. It's a graph from for low Earth orbit, where you can see in the x-axis the semi-major axis and in the y-axis the inclination. And for each orbital slot, we can calculate the collision, the cumulative collision probability over 15 years due to a possible fragmentation of an object in that orbital slot. So how can we evaluate the risk? We can say, what if a mission in that slot would fragment due to an explosion or due to a collision? If that would happen, that mission would influence the overall environment depending on the orbital dynamics, and therefore we can highlight different areas with different colors. And this can help us to calculate the so-called space debris indexes, so the indexes that evaluate the risk that a mission creates on the environment. We can evaluate that for different objects, for different families of objects, and for different possible evolution of space. So, for example, we can see how you can recognize the sun-synchronous orbit that, of course, is very busy, and therefore there the risk of collision is higher. But we can see as while the environment changes, the area where the major risk is will change in new orbital region where space activities can develop. Of course, we need to go back to the positive way. So we need to think that space is contributing to life in many aspects, and therefore we cannot stop the evolution of space activities. We need to foster it, but we need to learn and work together to make it in a sustainable way. So space in itself must be sustainable, and solutions for a sustainable development of space need to be quickly defined, agreed, and implemented. And therefore, action will be needed toward the definition of the space carrying capacity, measure, and threshold. And with this, I conclude, inviting you actually to one of the next event, to a road to the IAC 2024 that will be in Milan. So you can already check hotels and accommodations to see if you like them. In June, actually on these topics of space capacity allocation. For information, you can contact IDA.
Thank you very much, Professor Colombo. Very interesting presentation. We are running out of time. Just the last couple of minutes to show the video prepared for the IAC 2024. Thank you. Thank you very much again. I hope to see you all in Milano next year.